Hello, this is Forensic Wow. We're going to be simplifying that with numerical expressions and with algebraic expressions. This was a request by Mr. S. 10 to the 0 equals 1. Anything to the 0 is 1, no matter what. All but 0. Nothing but 0. Just 10 to the 0 equals 1. 3 to the 0, 1. 100 to the 0, 1. 1 million, 2 million. 4 to the negative 10th. We would convert this into a fraction, which would be 1 over 4 to the 10th. Because right here, okay, there's a video. Okay, there it is. Right here, that 4 is over 1. It's over 1. And you have to convert that. Okay, so 5 to the negative 4th. 5 over negative 4 to the negative second. That would equal. Wait, that's the wrong one. That's the wrong video. That's the wrong one. That's not the wrong video. Okay, there. This one. Trying to focus on my camera here. So we got, and that negative second will go up. We'll make that thing go up. Make the 4 go up with the 5. So that will be 5 times negative 4 to the second. In the operation thing, with order operations, in order operations, the exponents are first. So we would do this, and that would equal 16. Because anything times a negative times a negative equals a positive. And then we carry that 5 down. Now I don't know how to do this, so I'm going to be using lattice like in one of my other videos. That's 15, 0, 6. That's going to be 30, 0, 0, 0, 0. 6 times 1 is 6. So that's going to equal 9D. So that answer equals 5 times 16 equals 90. Five to the 6 times 5 to the 5th. All you're doing is just adding the exponents on this one. 6 plus 5 equals 11, so it'll equal 5 to the 11th. X to the negative 7th. X to the negative 7th equals 1 over x to the 7th, because there's a 1 over here. And that's the same thing. And if you converted this, if you went to solve this, and if x was a real number, you would turn it. It would be a decimal, and then when you turn it into a fraction, it would be like that. It would equal the same thing. So 5x to the negative 7th. This is 5 over 1. 5 don't have an exponent, so that's going to stay there. The x has a negative exponent, so it's going to go to the bottom. The 5 has a positive exponent, which is 1. So that's going to be 5 times. So that's going to be 5 over x to the negative 7th. No, to the 7th. To the 7th. No. Sorry, my bad. To the 7th. Now this one is looks a bit tricky, but we'll get through this. So the 5 has no exponent. So we're going to equal this. 5 has no exponent. Well, actually it does. It has a positive exponent, but no negative. So it's going to stay right there. So that's going to be 5. And what's next? X to the negative 5th. That goes on the bottom. So that's going to be x to the 5th on the bottom. We got y to the 3rd. So that's going to be 5y to the 3rd. And then we got a to the negative 9th. So that's going to be a right there to the negative 9th. Hope this helps. And this is our last problem of the day. Negative 5 to the negative 4th, x to the negative 2nd, and y to the 1st, 5 to the 3rd. So this is gonna, so that's negative 5 to the negative 4th. And that's going to go, so negative 5, that's going to go on the bottom. Always keep that parentheses. Since there's parentheses, you're multiplying, you're using, you have that the exponent is doing the negative also. So when you're doing that, make sure if the negative was out of the parentheses, you are not doing it correctly. It means that you're just adding the negative, not getting rid of it. Sorry, there I had a mosquito. So that's going to be negative 5 to the 4th. We're just simplifying what's here. X to the negative 2nd. That would go down with it. X to the 2nd. Y would be on top. And 5 to the 3rd would be on the bottom. Now let's combine like terms. So 4 times 4 plus 3 equals 7. So that would be yeah, let's just leave right there. To simplify, yeah, let's leave it right there. Because then we're gonna have